Welcome grade 12s, and today it's one of our last big pushes. Today what we're going to do is we're going to review some of the prelim papers, okay, and we're looking specifically at physics. And what we're going to do is we're going to do something a little different because we normally just do long questions, but multiple choice is actually a skill. And I know for a lot of you it's a little bit of multiple guess and you try and make pretty patterns out of the A, the B, the C, the D, and off you go. But it actually is a skill. So we're going to jump around a little bit. So for the first little bit, we're going to do some multiple choice. I'm going to give you some time to read through the question and to answer it, guys. What I want you to do when we do these, please, you don't learn anything if you just guess. So I know I'm going to be giving you probably more time for some questions than you need, but that's okay because I want you not just to give me the right answer, which is important, but I need you to be able to explain it. So in your own head, you need to be able to explain why you chose that answer or why you didn't choose the others, okay? So don't just guess. I want you to work through them, all right? So let's look at the first one, and I'm going to give you a minute. I'm not going to read these with you. I'm going to let you read them. So you're going to have a minute, and your time starts now. All right, grade 12's time's up. So let's have a look at the first one. First of all, we're going to look at the key words. It says which one, okay, there'll always be one, of the following forces always acts vertically downwards. So we're looking at something that's going to act down. So now we go and we say, okay, well, normal force, if we have an object on a table, well, my normal force acts vertically upwards, so it's not the normal force. Frictional force, well, frictional force is going to act in the opposite direction to motion, so that's not either. Applied force, well, the applied force might be up or down, but it doesn't always have to be vertical, so no, it's not the applied force. Now they say gravitational force, well, gravitational force will act, oh, look at that, vertically downwards. My answer is D, because that's the force that will always act vertically downwards, okay? And did you see how I worked through that? I worked through each of them individually before I got to the final answer. Okay, let's do another one. So here you go. And I'm giving you a minute, and your time starts now. Okay, time's up. And I know grade 12s, these are the ones you really hate. So let's see what the question says. It says an airbag can protect the driver from serious injury during a collision. Which of the following best explains why this is possible? Now remember, an airbag uses the whole thing of impulse, which is F net delta T equals change in momentum. So we know change in momentum stays the same, and the whole point of an airbag is it increases stopping time. It takes longer to stop. So if we just look at the time of impact, we go, well, it can't be B because it says time decreases. It can't be D because it says time remains the same. So now it leaves me with A and B. Now we've got to remember here that if we look at the equation, if T is going to get bigger, but my change in momentum remains constant, the only way that can happen is if T increases, then F net gets smaller. So it has to be C because my force decreases. And of course, that's what we want. The whole point of an airbag is to reduce the force that we experience. Okay, otherwise it wouldn't be worth anything. So that gives me C as the answer. Okay, next one. Here we go. Ooh, now we're going to Newton's Laws question, and you have a minute, and your minute starts now. I'm pretty sure grade 12s, most of you have been sitting there for the last 45 seconds going, really? This one's not hard. This is a nice question. It says to us, when a bus suddenly accelerates from rest, standing passengers tend to fall backwards. This observation is best explained using. Without even looking at the options, you should know that we fall backwards because of inertia. And what law is explained using inertia? Newton's first law of motion. So it has to be A. And you know what? These were only put in this order. It's only A because they put in an order that you learn them because it makes it easier. Okay, so that was nice and easy. There we go. The current in a potential difference graph below shows me 4 resistors. The question is the resistor with the second largest resistance is. So there they go in order. Okay, so there's the question. Which resistor is the second largest resistance? You have a minute and your time starts now. All right, grade 12s. How many of you went, this is easy? Off you went. And I promise you it wasn't as easy as it looks. I like this question. Please be careful with these. The point here is that they've changed around the way you normally see this graph. This graph is normally potential difference over current. Now they wanted the second largest resistance. Resistance for these graphs will be the gradient. Okay, so if they want the second largest resistance, it would be the one with the second largest gradient, maybe. So probably a lot of you thought it was Q. However, R equals V over I. This isn't a V over I graph. The gradient of this graph is I over V. Okay, that is the same as 1 over R. This was the trick here. That's the same as the inverse of the resistance. That means that the bigger the resistance, the smaller its gradient is going to be. So my option is actually C. It's S. All right, it's that one. Simply because T will be my biggest resistance because it's going to give me the smallest gradient using 1 over R. P will be my smallest because it's going to give me the biggest radius gradient with 1 over R, so it has to be S. Please be careful. Look at what they're writing on the sides, okay? So, question 5, here we go. It's a little more reading, but that's okay. This is a very important question as well. So, you have a minute and your time starts now. Now, grade 12s, a question like this is one that you should answer before you look at the options. So they say to us, the line emission spectrum is produced when an electron in an excited atom makes a transition from. If you don't know your theory, doing this, looking at the options isn't going to help you. Now, remember, it's an emission spectrum, which means we need to emit light. That's the first thing. Second thing is the only way energy can be given off is if the electron jumps from a high energy level to a low energy level. Remember that your electron absorbs energy because it's through a cold gas, so it absorbs energy when it gets heated. That energy makes it jump up to the next energy level. Once it gets up there, it can't stay there. It's excited, but it's not stable. Once it gets up there, it's got to jump back down, and when it goes back down to a lower energy level, it emits energy as it goes. So let's look at the options. A says higher to lower energy level, great, and emits light energy. Perfect, so A is an option. Higher to lower, great, absorb energy. No. Lower to higher, no. Lower to higher, no. No, I've done it again. That makes A my option. Okay, so that's really important. That makes A your option. Okay, last multiple choice question. Here you go. Okay, I'm just going to put C, this option for C over here so that you've got it because I want you to see the whole question still. So there you go. And you have a minute and your time starts now. Okay, grade 12s. Honestly, a minute probably isn't long enough for one of these questions, but that's okay. Two small identically charged, positively charged spheres, P and Q on isolated strands, place the distance d apart as shown. The magnitude of the force between them is F. If the distance is now changed to a half d, the new force, or I should say force, between the spheres is. Guys, don't even look at the options because that's going to confuse you. Now remember, F for this is K, Q1, Q2 over R squared. Okay, that's what we want. Q1 and Q2 aren't changing, so what's changing is R squared, which is at the bottom, because remember, F is inversely proportional to my distance squared. So now if I halve the distance, okay, so this becomes 0,5 and it's d squared, don't stress about that. Actually, that's 1 over 0,25 d squared. Now, if I go and put 1 over 0,25 in my calculator, that gives me 4. That tells me, and it's because 1 divided by 0,25 is 4, that tells me that my force is going to become 4 times bigger. The answer is D. Please be careful with these questions because these are the ones where you have to look at the ratio, okay? So, we've done some multiple choice. What I need you to do in the breaks, I need you to find your information sheet because you're going to need some information from it for the next question. All right, so it's not given to you, it's stuff that's implied. So make sure you find your information sheet, find in the back of your textbook or an old question paper, wherever you need to get it. We're going to take a short break and then we're going to do a couple more questions. Welcome back, grade 12. So what I decided to do with this is now we're going to tackle a Newton's law of universal gravitation. It's actually a really nice question, and it's got a little bit of a trick at the end, which you don't see very often. So now what we have here is we have a spaceship of mass 3,500 kilograms, okay, which is at rest at a point P, which is 2 times 10 to the 5 kilograms. Now watch here, from the center of the Earth. Okay, so now the first two questions say to us, state Newton's law of universal gravitation in words. Very important that you can do that. And then I ask you to calculate the magnitude of the gravitational force that the spaceship experiences at point P. Okay, so it's a fairly straightforward question, all right, but because there's some calculations in it, I'm going to give you 3 minutes, and your time starts now. I'm really hoping grade 12s that we didn't struggle with this one, okay? So let's just go through what you should have got. All right, now the first one was to state Newton's law of universal gravitation in words. Guys, these are laws. Please, please learn them, okay? So what Newton's law says to us is that each body in the universe, okay, because it's universal, in the universe attracts every other body, okay, every other, I'm going to run out of space, I'm going to try to fill it in, every other body in the universe with a force, okay, now watch here, this is the important thing, that is directly proportional to the product of the masses, okay, you've got to put the word products, product, oh, look, doesn't like me, there we go, product, there we go, product, not products, because there's only one product of the masses and inversely proportional to the square of the distance. Now watch here, this is the important part, distance between their centers. Okay, so it's a good thing I write skew. All right, so product of their masses directly proportional to it. So the bigger the masses, the bigger the force, inversely proportional to the square of the distance between them. So the further away they are from each other, the smaller the force. Now, with the spaceship and the satellite, first of all, this is why I needed you to get your information sheets. You need to know the mass of the Earth. Now, the mass of the Earth, which you get off your information sheet is, and I'll tell you now because I don't know this off my head, is 5,98 times 10 to the 24 kilograms. That's not a problem. Mass of the spaceship was given 3,500 kilograms. Now, distance is the issue here. Watch what they say here, okay? And I've just realized that I've made a mistake on my answers. So I'm going to need to open the calculator quickly. So give me a second here, because I should have opened it earlier because I've just realized my answers are incorrect, because I'm now going to show you why reading the question is so important. Because over here, when I did this at home, and I would have got this wrong, is I didn't read this properly because now it says from the center of the Earth. And what I did, silly me, is I actually took this value and added it to the radius of the Earth, which is this, 6,38 times 10 to the 3. This explains a couple of things. Now, that makes the distance really, really big, which makes the force of attraction really small, which is fine. That wasn't the issue. But I added it to that distance, and in my head I should have actually realized that makes it ridiculously far away, and that's never going to work. So yes, and actually it makes life easier in the next question too. You know, sometimes we do silly things. So it is from the center to the Earth. So I don't need to worry about anything else there, because my radius that we have to use is 2 times 10 to the 5. That was all I needed from my information sheet, and I needed G. So F equals G, mass of the Earth, mass of the spaceship, over R squared. If you left it as M1 and M2, that's not a problem. G, of course, is that really, really small number, 6,67 times 10 to the minus 11. This is 5,98 times 10 to the 24. This is 3,500. And this is 2 times 10 to the 5 all squared. So now I go to my calculator. I definitely can't do this in my head. So 6.67 to the minus, there we go, to the minus 11 times 5.98 to the 24 times 3,500. Okay, I'm now going to divide that by 2 to the 5 all squared. And I'm going to put this into scientific notation because it's going to make life a little bit easier, which gives me 3,49 times 10 to the 7 newtons. Okay, not a bad number. Okay, now let's go to the next question. Now they say to us that point Q is on a straight line between the moon and the earth. Q is a distance d from the center of the earth. The spaceship experiences a zero net force when it is at rest at Q. The mass of the moon is 7,35 times 10 to the 22 and is an average 3,8 times 10 to the 5 kilometers from the earth. I have no idea why I didn't get the wrong answer. Anyway, calculate the distance between points P and Q. That's the distance that I want. Okay, you have 3 minutes and your time starts now. Okay, grade 12. So when you look at this question, I'm pretty sure some of you went, oh, no, I'm not doing it. It's horrible. Ooh, pen was upside down. I want to make my pen a little thinner because I want to make it a bit easier. This really isn't a bad question. And I chose this one because of the fact that it's universal gravitation using net force. Now, if my net force at Q is 0, that means the force of attraction between the spaceship and the Earth, let's call this Earth and the spaceship, and the attraction between the spaceship and the moon, those two forces must be equal because they're pulling it in opposite directions. That was the science in this question. So when I start off here, I've got to say that the force between the Earth and the spaceship must be equal to the force, but, oh, that's an E. That's not what I wanted because we're not, there we go, between the force of the moon and the spaceship. So here I would use G, mass of the Earth, mass of the spaceship, over my distance squared. I'm going to use G, mass of the moon, mass of the spaceship, over R squared. Okay, let's call that R1 and R2 because they are different. Now, G is going to cancel out for both of these. Okay, so I'm not going to worry about that at the moment. And you know what? The spaceship also cancels out. The mass of the spaceship makes it much easier. So, the mass of the Earth, I told you, was 5,98 times 10 to the 24. Now, the distance between the Earth and the spaceship now is D, so that's D squared. The mass of the moon, they told me, was 7,35 times 10 to the 22. But now the distance here becomes important because actually it's only between there and there. We've already got D, so that distance is actually 3,8 times 10 to the 5 minus D all squared. And you know what? You've got 4 out of the 5 marks. No, 3 out of the 5 marks already, just by doing that. Now I know from here, and I wouldn't normally do all the maths, but I'm going to show it to you because I think it's important. From here, the wheels tend to fall off a little bit because now we've got squares and we get all difficult. But you know what? What we're going to do here is I'm going to square root both of these straight away. Okay, because what happens then is if I square root the top, this becomes 2,45 times 10 to the 12 over D. This becomes 2,71 times 10 to the 11 over 3,8 times 10 to the 5 minus D, because that bracket disappears. Now it's a maths problem. Okay, and what I would do here is I would actually take the fractions away. So I'm going to take these and I'm going to times both by this. Okay, so this is what I'm going to do. All right, now don't lose me just yet. So this is 2,71 times 10 to the 11D. Now from here, there's lots of ways to do it. I don't like multiplying out the brackets. What I actually do is divide both sides by 2,45. Okay, because then I get this. Okay, I'm going to take the D over, and this gives me 3,8 times 10 to the 5, and it's equal to 1,11 times D. Divide that by both sides, and D is 3,42 times 10 to the 5. But we're not done, because the question was, if we go back here, is not for D. They wanted to know what the distance between P and Q is. Now, earlier on, they told us that, the distance between P and Q. Now, in the first question, they told me, now watch here, that P was 2 times 10 to the 5 kilometers, okay? So this distance over here, from here to here, was 2 times 10 to the 5. I want this little piece, so I'm going to go D's value minus 2 times 10 to the 5. So, watch what I'm going to say. My distance, now let's call it delta x. So delta x between P and Q is 3,42 times 10 to the 5 minus 2 times 10 to the 5, which gives me 1,42 times 10 to the 5 kilometers. Don't forget the last part. Okay? We all okay with that? I hope so. Well, I think it's time for a little break, so take a quick break, grade 12s, and I'll see you in a couple of minutes. Okay, so last bit, we're going to look at photoelectric effect. We can do this, grade 12. So here's the question. Different frequencies of light are shown. I'm pretty I think I spelled that wrong. So anyway, they shine onto the surface of a metal. The graph below shows the relationship between kinetic energy of the photoelectrons and frequency of the incident light. Now, I ask you to refer to the graph and write down the threshold frequency. Okay. And then I ask you to give a reason why no photoelectrons are released when the light has a frequency of 45 times 10 to the minus 19 hertz. So, shouldn't take you too long. In fact, I'm only going to give you a minute, and your time starts now. Okay, time's up, grade 12. So let's see how you did. So, first part of the question. What they're wanting you to see is what's important about the information given to you on the graph. Okay, so this is in times 10 to the minus 19 hertz. It makes it easier for us. It says refer to the graph, write down the threshold frequency. Now, here you've got to remember what threshold frequency is. Your threshold frequency is the minimum energy, is the minimum frequency needed for electrons to be released. But remember, when we use threshold frequency, the kinetic energy is 0. That means it is the intercept on the graph. So that means my threshold frequency here is 50 times 10 to the minus 19 hertz. Okay? Now the next question is dependent on it, because it says give a reason why no photoelectrons are released when light of frequency 45 times 10 to the minus 19 hertz is used. Now 45 would mean that it's over here. Well, the graph hasn't even started yet, but we know that the threshold frequency is 50 times 10 to the minus 19. They're only using 45. So what we say is that 45 times 10 to the minus 19 hertz is below, that's a B, below the threshold frequency, thresh with a R. Hello, didn't want to get all of that, is below, I'll write it so you can read it. I think that's a good idea. The threshold frequency, therefore, no electrons will be ejected or emitted. Okay? Brilliant. So, next question. Here we go. Same thing. Now it says, calculate the velocity of the ejected electrons when a light of frequency 110 times 10 to the minus 19 hertz is shone onto the metal. I'm going to remind you that we've just said that the threshold frequency is that, because you're going to need that, okay? And just in case you don't have your information sheets, the mass of an electron, because you're going to need this, is 9.11 times 10 to the minus 31 kilograms, okay? So now I'm going to give you 3 minutes, and your time starts now. Okay, so grade 12s. I think with this one, this is really more a bit of a maths problem than anything else, and that's why I gave you so much more time, because as soon as I see the fact that I have to do the velocity of an ejected photon, I know I'm going to have to use this equation. And remember, this is actually EK. That's the equation I've given. Now, I don't know the energy of the photon, and I don't know the work function, but I can work them out. And this is what makes this such a horrible question, because remember, if h is Planck's constant, well, I probably should have given that to you, sorry, 6,63 times 10 to the minus 34. They told me that it's 110 times 10 to the minus 19. That's still 6,63 times 10 to the minus 34. My threshold frequency was 50 hertz, 50 times 10 to the minus 19. Okay, plus, and I told you that the mass of an electron is 9,11 times 10 to the minus 31 times v squared. Now, out of the 5 marks, you've got 4 out of the 5 already. Okay, now what will happen here is I'm not going to do all the bits and pieces. I'm going to actually show you what I would put into the calculator to get the v squared on its own. I'm going to end up going 6,33 times 10 to the minus 34 times 110 times 10 to the minus 19. Then I'm going to minus the 6,63 times 10 to the minus 34 times 50 times 10 to the minus 19. Okay, and that, of course, would be equal to a half times 9. All right. So that would be the first step. Then I'm going to let's take the 6,63 out, because that's my common factor. Okay. All right. Then I'm going to divide it by 0,5 times 9,11 times 10 to the minus 31. But remember, I want v, so actually I'm going to square root that whole thing. That gives me v. Okay, now I would put that all into my calculator. So if you go here and we say, fine, let's see what we get. Okay, so putting it into my calculator. There we go. Okay, I'm going to go 6.63 to the minus 34 times 110 times 10 to the minus 19 minus 50 times 10 to the minus 19. Okay, then I'm going to divide that by a half times 9.11 to the minus 31. Okay, now I'm going to take that answer and square root it. So I get 9,35, which is actually quite big. Okay, it's actually quite small, but that's okay. 9,35 times 10 to the minus 11 meters per second. How you do the maths once you've done all the substitution, they don't actually care. Okay, as long as you get there, and all of you will work that differently. So, last question. Now they say, what effect will an increase in the intensity of the radiation have on the velocity of the ejected electrons? Right, increase, decrease, or stays the same? Explain your answer, and you have a minute, and your time starts now. All right, grade 12s, how many of you said it'll increase? Because you went, increase in intensity, increase. No, read the question. It says increase intensity have on the velocity of the electrons. Guys, be very careful. If we increase the intensity, we absolutely will increase current because we'll have more photons hitting the electrons, so more electrons will come off. However, considering that we're keeping the energy the same, and remember this is what we're looking at, if this remains the same, then the kinetic energy will remain the same. And if the kinetic energy remains the same, then the velocity remains the same. So my answer here is it stays the same, not remains the same, stays the same. Okay, because that's what they told me to use. So stays the same. Why? The frequency is constant. Okay, therefore, energy of the photon is constant. Of photon constant. Therefore, EK doesn't change. Okay, very, very, very important. All right, so we've done a little bit of revision. We've covered a lot of sections, not as much as we'd like, but only with an hour. There's only so much we can do. Practice, 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 practice. Grade 12s, you're almost at the end, and I will see you again next time.